Okay, so today we're going to be learning about how to use our textbook. Seems a bit weird, I know, but we're going to be doing our first in-class exercise today, which will involve learning a little bit of Python, mainly looking at it. Primarily looking at it and seeing that we can read and understand quite a bit of it, within reason. Now, reading isn't necessarily the same as being able to write that. Your first homework, your first lab, if you've already looked at it, is basically involves being able to print out statements and things like that. But we're going to be looking at a bit something that's a bit more complex. Now, before I get started, a few things. First, I don't think I properly introduced myself last class. I just kind of started and jumped into it. So I am Professor Rosen. I teach this class as well as 2168, so first programming class and essentially the third programming class for most people. I wear a whole lot of hats here in this department, but of note is that I'm the advisor for our data science programs, the computer science physics dual degree, the computer science mathematics dual degree, the accelerated 4+1 program, so getting a master's and bachelor's in 5 years, as well as the computational data science masters. I am also the faculty advisor for the TU Dev Club, which is one of the hacking clubs here, and just kind of putting stuff together clubs here, as well as the faculty advisor for the TU Gamers Guild Club, which is not e-gaming, but all kinds of gaming, including tabletop games and video games. Oh, and I occasionally teach at Temple Japan, so if you have questions about Temple Japan, you should probably ask me about that, because I've probably been able to answer a bit more than other faculty members are. And that kind of undersells my contact with them. So, anyway, there's a lot of things you can ask me about, and you aren't limited to just asking me about 1051 during my office hours or during any kind of meeting, right? If you have questions about the data science program or any of our programs, if you have questions about other classes or just general advice, it's literally my job to answer these kind of questions for you. So don't be afraid to ask. Now, with regards to today's stuff, we will be doing Runestone, but it's worth just kind of showing you that, as a reminder, now that it's live, that you can go, if you missed Tuesday's lecture, or for some reason you missed today's lecture, you can go over here to lecture recordings and click on it. The link is also over here, as well as a link to our Discord. But the lecture recordings, we have a playlist for this semester. It currently just has one video in it, and it's an embedded playlist. So as we do more and more lectures, that list will get longer and longer. So this video, each video here is not a single video. It's not just the first video. It is all the videos from those previous lectures or previous semesters. So if you missed it, it's right here. I try to upload it the same day. Sometimes I need a reminder, but I will get those things. But I do get them uploaded. So if you need that, that's there. Again, every week we kind of figure out what we're doing. Every week I have it kind of laid out module by module what we'll be doing, so you can figure it out pretty easily. Now, once you create a Runestone account and set up these things, you will be able to click on these links and they'll take you to your assignments over here, which I'll show you how to access. But it's a list of all the assignments and their due dates. Unfortunately, it's in the reverse order of what would be useful. But to be on time with everything you need to have again, these are soft due dates, so there's no issue with them being late. You need to have your readings done for the chapter 1 by tomorrow. It's just basically stuff over here. And the way you do that is you just kind of go through the textbook, click with through the interactables, and see how it works. I'll show you that in a bit. And then you have exercises, which will start out as just being, your standard multiple choice questions, as well as an introduction into being able to interact with the textbook. There are often a lot, just like a math textbook, there are tons and tons of exercises per chapter, and I'm not going to make you do every single one of them, right? So that's the entire point of having this link to this exercise, so that you can be pointed to those exercises, the ones that I want you to do. And you don't have to go through Canvas to get there. Canvas just makes it easier. For instance, today's exercise, you can click to get there through Canvas, but I'm going to show you through Runestone how we get there, okay? Now let's see. So let's see, our TAs have started to put in their information. I need to update David, since he's not actually in a TA this semester, although he is just definitely if you're interested, though, in finding out more about TU Dev, David is the president of TU Dev, and you can grab his email over here to ask questions about that. So he's generally a good person to know on campus, just because of the breadth of knowledge he has about not just computer science or and IST stuff, but also just generally the stuff at Temple. All right. So let's get started with the textbook. If you haven't signed up for a Runestone, so let me start from the beginning, actually. So if you haven't figured it out yet, I utilize a free textbook on the website runestone.academy. It is a big project to basically provide free textbooks for computer science education. And I hate the textbook industry. In fact, I've been working on, for the past couple of years, very slowly I should add, my own textbook for data structures, because that is a project of spite, because I plan on releasing it for free, because I hate the textbook industry. It's not a labor of love, it's the opposite of it. And so, we have this, but anyway, as a result, we do have this free textbook. It is Foundations of Python Programming. And the way you get access to it is we can click here to get to runestone.academy. If you do not have, if you've created an account and followed the directions already, great. If you haven't, here's how we get started, right? Register and get started. Sign up page down here. Or the other way to get there is you hit the login and you click this button, sign up, right? It's the sign up page. So again, two ways to get there, in case you kind of missed that very quickly, is we get there via hitting the register and get started. And then it tells you, hey, where should you go? Take me to the sign up page. Or you hit the login button. Okay, here, I'm gonna log out. You hit the login button, and you're like, of course, I don't have an account yet, so I hit the sign up. Right, and you should follow along with this now if you're not registered yet. Then you want to create, your account. So here's the way this way we want it to work. Username can be whatever, right? Your first name should be what's listed on Canvas, okay, as your first name, and your last name should be what's listed on Canvas as your last name. Sometimes that gets tricky, especially if you're like my wife, who happens to have Annie-Ray as her first name and no middle name, so it can get so sometimes this can make systems very confused as to what your name actually is. So as the other field, I want you to fill out your email as TU, whatever your email address is. So normally you'd be sending it to andrew.rosen@temple.edu, but actually that's just an alias for this email address, 85861, TUG85661 @temple.edu. So I want you to put in whatever your TU email is, whether it's TUH, TUZ, TU, right? And as long as one of those two things match, my script will be able to help when it comes time to import these grades into Canvas, my script will be able to pick it up. I wrote a Python script to to merge these two things. And we will be looking at that later in the semester when we go over file reading. Okay, obviously create your password whatever you want it to be. If I need to, I can always send a reset. And then for the course name, to sign you up for the correct course, you want to do Spring 2026 Rosen. All one word, Spring 2026 Rosen, all lowercase. I agree. There's no need to create a course. Yes, you could ostensibly, the ones of you who will make great hackers are thinking, wait, can I just create my own course based off this textbook so I could look at the answers? And the answer is yes, kinda. You'll see soon why you already need to kind of know programming in order to make use of that. And at that point, you'd already know how to answer those questions. I can always show you guys this part of it later. Once you signed up, you'll be logged into to our course, and you'll be brought to this landing page. All right? And so there's basically a few different ways to do this. This is just kind of a general overview over here. I'm obviously very zoomed in, just so simply that people in the back can see. It generally looks more, easier to look at from your own computer, but again, I keep it zoomed in. And you can kind of go through and see, okay, here's when things are due. I may adjust some of these. These were automatically imported and adjusted from last semester, so it may or may not be reasonable, but I can adjust these as needed. And again, there's not a penalty for these being late. And this will tell you what you need to read. Or you can just go directly to our textbooks over here. Okay? And it will show you what you've read and things like that. Again, and if you want to go and see the other assignments, like to go and see the assignments, the readings and the exercises you have to do. Say you're on this page and you need to go and see all the stuff you have to do. You go click on assignments. And, I bet you don't see them yet. Give me a second. Boom, boom, boom. Because I bet you I copied them over. See, this again, these are the quirk things. And I didn't make them visible. Haha, that's right. Let's make some of them, let's go ahead and make them visible. There you go. Let's just get the first batch of stuff visible for all the students. Okay. That way it's not too overwhelming. So now if I go to our assignments over here, we'll see, hey, we've got the first 5 chapters assigned, and you can see they've got due dates up through the month, right? So nothing, so even though it's a lot, it's actually spread out, but I figure that way, you can get a handle of it without it looking like a huge, overwhelming list. Okay, so let's see. So you click on them and it will tell you, hey, you need to do these things. To complete these things, right, to mark as complete, to get these, it will tell you how many activities you have to do. Activities generally can basically mean clicking on the interactables in the page, such as this YouTube video, right, or running code, right, and answering questions, right. These things are in readings. These are always done for like credit, for like, did you interact? Yes, you could speed run your way through it as opposed to reading it, but like again, that defeats kind of the purpose of me assigning it. And this will have and for this first one, again, it just kind of goes into the general idea about language and how you can use the Python in this textbook, which is kind of useful. As well as going into the Code Lens, which is an extremely useful tool for going step by step through the code. It's fantastic. Okay. Now, so hopefully, does anybody else need time to sign up?
I need to reset my password.
You need to reset your password. Okay. Do you need me to do that? Okay, give me a second. Unpause, because you can do that. And now what we're going to do is is that we are going to go to our first exercise. Okay, so there's a couple ways to get there. The first way is we click on the link directly from the module page. This wasn't correctly set up last night, and I fixed it once one student pointed it out. But if you click on this, it'll take you to to the preview of the end goal page, which is the exercise we're going to work on. If, however, you're on Runestone and don't have your Canvas page open, right? How do we get there? Go to, suppose you're on this page. Go to the textbook, which will bring you to this page. The projects are listed in the appendix, so you scroll all the way down, a bit up, to hear where the projects are. Make sense? And then we're going to click on the first project. Okay? So take a minute to get there, right? You can get there by going through the website or by going through Canvas. Either way works. Okay? So just take a minute to get there. Anyone need more time to get there? I have no objections. Okay. See, I'm used to dealing with the speed at which fall freshmen move, which is very, very slow. All right. So computer programming is honestly pretty great. I love it. Otherwise, I wouldn't be here teaching it to you guys. You can do a crap ton with it, and it is applicable to basically every kind of field you might be going into, but it is, as I mentioned, a skill-based domain. It is one where you have to do practice in order to do this. Just like writing piano, just as playing piano, you're not going to be able to just sit down and do like amazing piano sonatas. You have to build up the skills to do it. If you're doing martial arts, you can't just go in and get a black belt on the first day. It doesn't matter how strong you are. You need to learn how to move your body and how to have leverage and how to protect yourself. Those kind of things. Right? So today what we're going to be doing is seeing kind of the flow of programs and seeing that programs aren't necessarily as scary as they might be, although they will look scary, and just kind of seeing what kind of an example of what kind of things you'd be able to do at the end of the semester. So we are going to be looking at image processing functions, which are already a bit of a doozy in programming. They're pretty they're pretty advanced stuff, in my opinion. But that's for writing it. Reading it isn't too bad, actually. So what we're going to be looking at here is a program that converts an image to black and white. Okay? And this is kind of the way our code looks in this textbook. Okay? It looks like this. We've got this giant block of code. We have the ability to save and run it. We can download the code for our own use later. We can do showed code lens, which is the line by line thing, which is useful for when we're learning for loops. And we have this bar over here, which we cannot change right now. We'll be seeing it, but that's very useful. It is basically a snapshot of all the times you just saved the program. So if you've horribly messed up somewhere, you can always rewind, which is useful. So let's take a look at this program. First, I'm going to hit save and run just to kind of show you what it's doing here. As I mentioned, it is taking this image of Luther College's bell and converting it from black to white. Sorry, from color to black and white. And we can see that there. It's not grayscale, it's black and white. So let's take a look at the actual code as it's doing its job. So you'll see here that we've got a line that says import image. Importing means bringing something in, so we can immediately know that basically this is something that we're bringing in something. Image here, you may not understand the context of that right now. We know what images are, but in this context, image is a package that says, hey, we're going to work with images. Def, process 11 image. Okay, this is the way, and as we'll learn, def means define function, and what we're doing here is a lot of programming is defining nouns and verbs here. Def here defines a verb, a function. They're analogous to a mathematical function, but it's doing an action. So that's why I kind of refer to it as a verb. And this function is the workhorse. It's what's going to be doing most of the job here. And as you'll see, we call it down here. We reference it. So we define this thing and then we execute it. Number 4, get the height and width of the image. Note that it's in a bit of a different color. And it's got the hashtag in front of it, right? Or the number sign or the pound sign, depending on where you're coming from. This is what we call a comment. It's the bit of code that we have. It's a bit of a code here that says, hey, computer, please ignore this. It's only for humans. It's not actually code. So we can write whatever we want here, right? And it's not going to have any effect on the code. The computer just sees our hashtag, it sees our pound sign, and it just ignores anything that comes after it, right? Right? Everything before it is fine, but everything after it gets ignored, okay? Now, if you're coming from another programming language, like Java or C, it's the same as doing this, which is, in other programming languages, you often do double slashes for a comment. So in Python, we just use this symbol. All right. So we can see that anything that is this kind of green color with a hashtag in front of it is just not code. So width is equal to get width, height is equal to image.getHeight. So you can see that the code, that the comment here is useful because it says get the height and width of the image. It's explaining what the code beneath it is doing. That's what I mean when I say the comments are for humans. So over here, we have width dot is equal to img, which is short for image, dot get width. We're getting how wide the picture is. And in height, we are getting img dot get height. Now, if you're coming from physics or chemistry or biology, you're probably screaming, oh gosh, there's no units, or thank God there's no units. That's right. We have to know what the units are, which can get a bit frustrating. In this case, the units being described here are pixels, which is a term you've probably heard many a time before, but probably never asked what is a pixel exactly, or what does it represent. A pixel is short for picture element. It's actually a term, picture element. And it gets harder and harder every year. But if you get really, really, really close to your screen and look, you'll see that your screen is made up of tiny, tiny, tiny squares. Each of those tiny squares is a pixel. It can be different. It's different sizes for different devices, right? There's actually typically a term for like the density of pixels, and those really pricey MacBooks, part of the reason they're nice and pricey is because they have a huge pixel density. Those screens are very pixel heavy, lots and lots of pixels. Okay, typically we see a lot of display. The standard for displays these days is 1080p, which is to say there's 1,080 pixels, rows of pixels, just from top to bottom. These pixels, right, and we're going to actually go to, no, it's not a movie. We want the Wikipedia page, believe it or not, because here the Wikipedia page is actually pretty darn good, right? We can see here an example, an exaggerated idea of the pixels, right? We zoom in, and we can see that any image on a computer is actually made up of tiny squares, okay? Anything that gets drawn on a computer is just squares. It's made up of squares, and then our eyes reinterpret it as whatever shape we need it to be, okay? Now, each of those tiny pixels in your computer is made up of subpixels, and that isn't actually too complicated, but we can actually see, here's a zoomed image of what those subpixels look like. A pixel is made up of 3 lights: a red light, a green light, and a blue light, for basically emitting color. So in order to produce a specific color, those lights get adjusted to a specific level. Okay? It's kind of like mixing crayons or markers, except it's the opposite. What do I mean by that? If I take a bunch of crayons, okay, and mush them together and basically just draw like I'm back to being 4 years old, right? And just draw it on paper. The more I add, the more color I add, the darker it's going to get. Same with paint, right? If I add a bunch of paint together, it's just going to get darker and darker and darker and darker until it gets completely black. With light, it's different, right? Because when we're painting or drawing, we are basically creating the surface that light is going to bounce off of. Here, we're working directly with light, which is different. If we turn on as much light as possible and add as much color as possible, we get white as opposed to black, right? We turn off the lights to get black. So it's a bit different. So just understand that, like, if your instinct is to mix, yellow and blue together to get green, it may not work out the way you think it is gonna, just because it works differently, slightly differently. It's a different color model, which is best not to think about. But anyway, that's all a picture is. It's basically lots and lots and lots of little lights, and they're so small that we can't really even tell. It's pretty cool. Okay, back to code. So these are, next on lines 7 and 8, we have for loops. For loops are going to be the bane of your existence for starting on week 3 and going through probably week 7. The first exam is what's going to heavily cover the for loop. But basically, to basically describe it, it's a way to do repetition, to iterate over something, right? We want to go through this. The entire point of this program is that it turned every color pixel into either black or white. So we need some way to automatically hit every single pixel, and that's what the for loop is doing. It's saying for every single row, so from top to bottom, I want to go through left to right. I want to go through every single column in our picture. So basically, if we run it again, you'll notice it's that this image, I'll zoom in even further, is going left to right across, and then it goes to the next, thing, and it's basically doing one little square at a time. Make sense to everybody? So we'll learn more about how to write these things and format them, but for loops are basically ways to iterate over things. So what we do is that we have this thing over here. P is equal to image.getPixel. So this just simply gets the pixel at that row and column. It's basically saying, hey, we're trying all valid column combinations, all possible combinations of those, and this just happens to be this pixel's turn. And we're going to call it P because writing out this thing every single time is going to get annoying. So then we've got 11, 12, and 13, lines 11, 12, and 13. Red value is equal to this, green value is equal to this, blue value is equal to this. Right? Remember what I was saying about those subpixels, how it's made up of red, green, and blue? Well, we get this value of red, green, and blue. Then it does a bit of math, and it asks a question. We ask questions in the form of an if statement. If red plus green plus blue divided by 3 is greater than or equal to 255 divided by 2. There's a lot going on there, a lot of math going on there, and it's a lot. And while the math is fairly straightforward, it's only straightforward if you have the context for it. Okay, first thing. I mentioned that basically that these lights could be turned on from one level to another, right? The current standard that we use is 8 bits for each color. Long story short, 8 bits means binary digits. This means, to skip to the end of this, each of those lights has a value from 0 to 255. There's 256 different stages for each of those lights, okay? 0 being off, 255 being as bright as it can get. And so we have all those stages there for each of those lights. So we ask how turned on is the red light, how much is what's the intensity of the green, what's the intensity of the blue. It's going to be somewhere from 0 to 255 because that's what fits in a single byte. More on that in a later lecture, but just know that those are those values. Now, if we add three values together and then divide by 3, it doesn't matter what those values are. If we add three things together and then divide by 3, we are taking an average of those three values, right? And that's exactly what's going on over here. We're adding the red, the green, and the blue, and we are asking what is the average of those three values, right? So obviously, if they're all as bright as they can go, right? 255 plus 255 plus 255, I don't actually have to do the math when I divide of adding them when I divide by 3 because I know I've got three 255s. Divide by 3, it's equal to 255. Okay, similarly, if they're all 0, their average is going to be 0. Okay? But anyway, we've got this greater than or equal to sign, which looks a bit weird when it's typed out like this, right? But it's the only way we really can do that on a computer. If it's greater than 255, divide by 2. Okay? Basically, it's saying, well, it's saying there's a half. So 255, there's a halfway between 0 and 255. If it's above this halfway point, that means it's like on the brighter side of being on. And if it's less than that halfway point, it's on the lower side. So if it's on that brighter side, if this statement is true, we set all the colors to true. We set all the colors to full on, which is white, and otherwise we turn off the color, which is black. So basically what we're doing is that we're going square by square, looking at each square and saying, hey, is the average of the colors on or off? Is it brighter or less bright? If it's brighter, we're going to turn it to white. If it's a darker color, like the sign is, right, we're going to turn it to black. That's how it figures it out. Then what we do is we simply we create a new pixel with that color, and we say, hey, replace the old pixel with the new pixel. Then all this simply says, all this stuff over here is just simply saying, let's load up the image we're doing this on, do the animation, and run this. Okay. Now, that was process 11, as it says, which is funny because we have we're starting at 11 here. We have actually all these processes over here. We have process 1, process 2, process 3, process 4, all the way through process 10 in this other code block. If we scroll, so let me get it to something that looks like what you'll be going through, right? Here's the preview of the end goal. Here's our first code block. Scroll down. Here's the second one, okay? And it will be initially like this. You'll want to hit show code so you can see it, and you can hit save and run just to kind of interact with it. And you'll notice it does literally nothing because it's literally just defining things. Anyway, so over here we have two images to play with. We have yawningsquirrel.jpg and we have the lutherbellpic.jpg. And what we're going to do is we are going to experiment. We don't need to really look at the code to kind of figure out what it does. We can run it and see what it does. And what we're going to do is we're going to just basically show you, hey, you don't really even need to know too much to be able to modify code and be able to play with it. Original is equal to image.image yawningsquirrel.jpg. Our final image is equal to process 10 original. And then this just simply creates that new image that we just rendered. Our goal is to figure out to complete this drag and drop puzzle by figuring out which of the 10 processes does each. So if we run this, for instance, we will get, we're running this on this squirrel, and we'll see what happens to our squirrel pic. It turned demonic. That is now going to live in my nightmares eternally. All right, so this, now, there's no demon squirrel option down here, so we're going to probably need to go through the other options as best we can to figure out what it is. So how do we go through the other options? We go to process 1 and run it instead of process 10. Let's see what that does. I'm going to give you time to work on this by yourself quite a bit. Okay, that took that and did something to that. Right, here's our original. Seems to have gotten a bit darker. What about process 3? I'm just going to skip around. Oh, turned it into what we would normally say is black and white, right? But we know that this is not, in fact, black and white. That's kind of the incorrect term for it in this context. We call this grayscale, where basically everything has been turned into a shade of gray. Okay? So I'll let you get started in just a second. The only thing I want to mention is that notice over here that all these are process 8, image, process 1, image, process 7, image. Image being the thing we're going to be taking in, and basically it needs an image to do its job. And we provide that image. Process 5 and process 6 are different. Process 5 needs an image and a number. Process 6 needs an image and a number 1 and number 2. And so this is very much a case of, so it's got open parentheses, rather than open parentheses, close parentheses, it's got open parentheses, image, comma, then something else, close parentheses. So the way for process 5, if you just simply try running process 5 as it is, we're going to get an error. It says so error down here, missing the required argument. So in order to get process 5 to work, we need to put in a number. And I recommend putting in a number like 1 or 2 for these kind of things. And we can kind of see what's going on here. And there we go. Anti-gravity swirl. So what I'm going to do is I'm now going to pause the recording, and I'm going to let you now it's your turn to work on these 10 things. Don't worry if you cannot get it done or you're having issues. When I feel that enough time has passed, I'm going to come up here and I'm going to go through it myself to go through the answers to make sure that everybody's on the same page. Okay? Now, also furthermore, please feel free to work with your partners work with the people next to you. Partner up, right? Collaborate. It's fine to be noisy, okay? And finally, the last thing. Let's say you mess this all up beyond all belief and it's all, it's just now a mess, right? Or you drop something and you mash your keyboard accidentally. So over here now, I said I'd come back to this. You've got this timeline, which you can now drag. And it tracked every single time you made a change. So if you had an issue, right, you can go back to when you didn't have an issue. Or if you've had an issue basically the entire time, you can go back to the original. So that's, which is great because I can imagine how panicked the first student was before they got to this, they implemented that. First student to make a mistake, I mean. All right, pause. So let's go ahead and look through at first. So we started off early on. We were during our test. We ran number 3, and I'm doing that one because I remember very distinctly what it was. It's grayscale, right? And let's see over here. Grayscale. Number 3. Now let's go ahead and see number 4. Number 4, I remember this one because I do this every semester. It rotated the image by 90 degrees. It kind of flipped it like that. I guess from your perspective, it's like that. Rotates by 90 degrees. Rotates by multiples of 90 degrees. Number 4 did rotates by 90 degrees. Process 2, what did we do here? I'm not going through them in any particular. Oh, haha! It's let's see. That kind of blew up. Very interesting. It widening and darkening are not very things here. I think it might be the Claridon because it made the darks darks and the lights lights, right? So I'll hold on to that one. Right, and let's go ahead and see number 5, shall we? 5, if we ran it, you probably got an error like this. saying, hey, it's missing a required argument, right? This is what I was mentioning. Process 5, it says it requires an image and a number. Some functions require more than one thing. This one requires two things. And if we run this, we will see that that if we run this, we get 1, 2, 3. Oh, I was good at the timing. 3 turns. So that's definitely the rotate by multiples of 90 degrees. Process 6. That required 2 numbers to run. A Y scale, it says. So we kind of already know from the variable names it's reporting what it's going to do. So I gave it 1 and 2. And let's see. Made our squirrel a bit long. So enlarges in the X and Y direction. Let's take a look at process 7. Going back to process 7, if we don't change the inputs, we're going to get an error. So if you give too few inputs, you get an error. You give too many inputs, you get an error. Got to give the right number. But it's very easy to figure that out because it tells you. We gave it 3, but it only takes in 1. So we're going to give it the image. And you might be asking, well, how am I supposed to know? And the answer is you know by looking at this stuff. You know by looking at the thing you're calling. Yes?
So I know you said with some of the image and the number,
Uh-huh.
and you said it's usually 1 or 2. Is that in the future will also be usually 1 or 2? Or?
It really depends on our problem. And a lot of times you'll end up writing these things, so you'll be defining how many things you need.
Okay.
But I would say for when we start writing these ourselves, we're only going to be taking 1 in or 0, right? So this one turned it into into more of a spooky than demonic, but converts image to high contrast, black and white only. This was 7. Okay. 8. Got 5 left. 8. That definitely made it lighter. What about 9? Darker. Versus 1, which I didn't go back to yet because I remember what it does. 1, which only darkened the corners. 1 was the vignette effect, only darkened corners. 8, Claridon. No, sorry, 8 was not Claridon. It was 8 was Leiden's image. 9 was Darken's image. I believe. Hold on. We getting ahead of ourselves? No. Process 9. I believe that darkens our image. 9. And now 2 should be our Claridon. Makes our lights and our darks dark. And then our demon squirrel at 10 converts it to only black, white, red, green, and blue, right? If we actually take a look, it looks predominantly white, red, and black. But if we zoom in or get close, we can see actually there's some green over here and over here. And its eyeball right over here, one single pixel is blue. Then we hit check me, and it said I'm correct. I would hope so. I'll get it wrong one of these days. Okay. Now, last part of our exercise, we do have a bit of time left, and we'll be able to get out a bit early. So our last thing is that we've got is that we can, Functions aren't necessarily are atomic in the sense that they do one. We try to make them to do one thing, and since we design them a lot of the time to do one thing, we can combine them together to do lots of things. So over here we have it gives an example over here of how you can nest those things. Now, when I'm teaching my intro class, I avoid doing this purposely. Okay, Python has a lot of very strong philosophies behind the right way to code. And one of them is that basically code is read a lot more than it's written, so you should strive for readability. And while this is readable to anybody who's had a semester of programming, it's not that readable to somebody who's literally just started. So you'll see that oftentimes, especially at the beginning, I'll break it up. These two things do the equivalent thing over here. They're just broken up into multiple steps. So anyway, let's take a look at this. We're going to run this. It takes the yawning scroll.jpg, throws it through process 1, then throws that resulting image into process 4, which rotates it once. So step 1, process 1, so take the original. We're going to take whatever image that is, and we're going to store it in step 1. Then we're going to take what was ever in step 1, transform it by process 4, and throw it into final. As we'll see on Tuesday, this equal sign is a bit deceptive because you're used to equal signs from mathematics, okay? And while I'm using the term equals, that's because it's honestly an easier term to say than assigns. But we do call this the assignment statement, the assignment operator. What we're doing is that you pretend that this variable on the left is kind of a box to hold some data in. And what we're doing is we're taking the information, whatever that is, on the right and storing it in the box on the left for later use. So here we're taking an image and we're going to be storing it in step 1. Then we take that image, put it in process 4, which gives us this resulting image stored in final, and then we draw that final image. Okay. It's often easier to think mentally. You should be thinking, oh, I see an equal sign. It's more like this, an arrow, like taking this thing from the right, putting it into the left. The reason we don't do an arrow is because this is less than negative, right? And then, okay, what about this? Well, that's less than or equal to. Well, what about this? Well, now we're just having to type 3 things, which is annoying. Some programming languages, the older programming languages, to really emphasize it, they did what we call the walrus operator, which looked like this, which is if you turn your head sideways, we've got the eyes and then the tusks of a walrus, hence walrus operator. This is still used in some programming languages like Google's Go programming language for doing some special assignment operators. Anyway, I'll probably revisit that more on Tuesday. But we can see this, and we can add in, anyway, we can add in as many as we want. We could add in step 2 is equal to, right, he was like, hey, you started typing when I was executing, I'm now confused. We could do process, let's see, I think process 3 was grayscale. And we'll take in step 1. So we'll take the original, throw it into step 1. Sorry, take the original, process it, that gives us step 1. Take step 1, right, not the original, process it, turn it into step 2. And then here's the key, if we're doing 3 steps, we got to change the step 1 to step 2, right? Otherwise, we'd kind of just be wasting time over here, not doing anything, right? We're taking an image and generating a new image. We're not changing what the image is a good way to put it. As we'll learn, when we're working with a program, it's a lot like negotiating with an evil genie. It's going to do exactly what you tell it to do. Exactly what you tell it to do, not what you meant. Okay? So keep that in mind. Right? If you're a D&D player, think about how carefully you have to word that wish spell, right? This kind of thing over here. I think there was about one person in the room who got that reference, so joy. Now, once you're done with this, basically you'll want to check off this kind of these responses over here. And it will tell you whether you've done all the activities on the page. So if you've interacted with everything on the page and gotten this correct, it should give you all 10 of those done, and you'll be able to get credit for it when I run the grader. So go ahead and work on that bit, and when you've got, go ahead and work on this bit, and when you've got something and you check this off, you're free to go. All right, and if you have any further questions, you can come up here and ask me. So we are ending. So we can end. You can end early today.